morning, everyone. Um, yeah, getting a lot of work in the recent days here as we move to Gas County in our increasingly misnamed series. What are we doing? We're using Gas City. We're trying to stand up a kind of company that's aimed to a purpose, that has sub departments that are primed to certain purposes, and that refuse to speak outside of the area of their expertise. The hope is that by building a repertoire of expertise in a certain area, we're going to get the right agent answering the right question instead of the wrong agent confabulating answers that aren't grounded and don't really get the job done. And the hope is that by doing this, instead of having even long-lived agents that are working through a sort of massive project that we might memorialize in a task tracker like beads. We're also personality is not as important. Doesn't matter if the security department like has a spy theme or the SRE department has a engine yard theme. That doesn't matter so much. But we would like them to focus with the lens of expertise, and particularly to be the stewards of a part of a company's knowledge base, right? And so, what we're hoping is that if we can get this pattern to work on one general task or one small company like design, and we're using build a mobile puzzle game as a kind of example or test case, it's media enough that there's a lot of different jobs to do, and it's also small enough that we can hope to be done within a certain like reasonable period of time, and then sort of try to take the meta process, if you want, of setting up a factory to do a job on the road to some other use case, and that way we'll be sort of vetting out our ideas about how should work be organized inside of the dark factory. How fast can we spin it up and let it run? Can we teach our mayors to do this for us with minimal disruption, hands off, with the goal that we, as the human at the top of one of these little companies or whatever, um, will have the privilege of being the CEO, have the ability to dip down into the technical weeds if we want to, but we'll have a certain level of trust that each department will kind of work and evolve into its own niche and get better and better at its job as it goes. That's the idea. So let's see where we got to last time. Last time, we're continuing to go through a series on Conway's law enforcement, right? Um, Conway's law is, and this is sort of like shoving together this concept of law enforcement, which I'm not trying to talk about the police. I'm trying to talk about referees, kind of, right? Or quality bars, something like that. And can we create a quality bar for Conway's law? And Conway's law, restated, is that the way your organization looks is going to be the way your software that organization produces is structured, right? And so, if you want to structure your software a certain way, then you should structure your org in that way to cause that to happen. Like, I definitely believe in a sort of strong version of Conway's law, which is that like whatever you put on the input into the organization is what you get on the output. And so I think that we see this in the small in agent programming in a lot of ways. Like if I have a sort of one-to-one relationship with a smart agent like Opus, and I ask it, hey, please build me some software to do a puzzle calendar game online. The first structure that you're going to get is a monolith, and it's going to look like the organization that you have, which is that there's one person in your organization and they're doing all of their stuff themselves. They know everything in this file, they know where it is, and they just edit that and update it. And what we have learned over the years in the software industry is that this will work up to a point, but it starts to collapse under its own weight, right? If we don't separate concerns properly, not just into multiple files, but into multiple modules that interact with each other in well-defined ways with, you could say, what we call cohesion in each module. We have a module that does a particular job and does all the things related to that job, and loose coupling, which means that it's easy for somebody else to use that module, um, and only in the ways that module expects to be used, right? And so the module, say like, mm, say that we're constructing a puzzle game, and one of the modules in that game might be to generate a new puzzle. We'd expect that module to handle everything about, say, the logic of that puzzle type, the rules of that game, ensuring the puzzle is completable, ensuring it only has one solution. Um, all of that stuff would be sort of hidden inside of that module. How it does the job is hidden, and the face that it presents to the world is, I'll respond to certain kinds of requests. You can ask me to do this job, and then I'll go do it. Right. And so I think that the generic software engineering hypothesis is something like, we could put everything in one file, but instead we break it into small modules. They're easier to test in small pieces. It's easier to understand the interactions between different modules, trace them, and it's easier to modify them. Certainly easier to modify the internals of a module without the rest of the software needing to be informed at all, and easy to understand the impact of changing something about the surface of a module if we understand who's calling it or how it's being used. And so we're avoiding a situation where changing a small line of code in this part of the program has a huge domino effect in other parts of the program. That's like the fragile way of programming, right? It's like, I can't touch this because if I touch this at all, then this stack of dishes is going to fall over. And I didn't really know that those stack of dishes were hanging off of this little fork, but it turned out that they had been built around it or they'd been stacked up on top of it for so long. Uh, and so we want to have exactly the opposite, right? We'd like to have, sorted piles of dishes, if you will, in that analogy, or structures that allow us to make those piles interact. See, dishes don't really interact. It's kind of a bad analogy. Anyhow, so yeah, it's been working through various tasks that we set to it in earlier sessions, all available on YouTube. I guess they're in past VODs on Twitch as well. And we came up with an initial set of agents that would do various jobs to prototype puzzle games for us and get them out to the mobile store. And we've been working our way back through this idea of Conway's law, going, hey, I want you to delegate work to the right expert. And that sort of required us to create this concept of departments that have this mission statement, if you want. And when work gets sent to them, the first thing they do is say, is this my job? In other contexts, in like a human company context, that might be a more um, verboten kind of thing to say. That's not my job. But in this context, where we have a lot of freedom to design our workers, to design areas of expertise, to spin up new areas of expertise if it's not covered already by one of our existing agents, we probably should be a little bit more sharp about who's managing that knowledge or that expertise for the company. Because that way we can ensure that eventually we want to route the right work to the right knowledge base. We want to build the right repertoire, right? And we don't need the security guy to be learning about deploying software for the SRE people. Instead, like, let the security guy do the security issues. Let them look for the memory leaks or that kind of thing. Another thing that we're trying to do with this is we just have an intuition that these models, they've been trained on everything, all the knowledge available on the internet, right? And nobody has all of that in their head at once, right? And so when you're talking to one of these agents, it sort of has a half knowledge of everything. You know, it's sort of like they might have a specific fact of trivia, or they might sort of remember it, and they might pass along sort of knowledge to you. But if I narrow down my focus and I talk to one that has been trained on a certain corpus or to pay attention to that, that's going to perhaps have bespoke tools that speak to that expertise, that might have cached some questions and answers that are related to that knowledge base, then the idea of that is that it won't have to have everything in the world in its consciousness and its top of mind. It doesn't have to pay attention to everything at once. It can just narrow in on its thing. And as time goes on, we might understand, oh, you actually need more and more context to do that job and understand that thing. And that's something that we're trying to write in as well, that they might evolve and grow into adjacent areas or related topics or something like that. Uh, but the initial idea, at least, is that it would be much better if we've designed our roles properly, if we have coverage for all the kinds of work that are being asked along the way. Eventually we're going to run out of robots to invent, and we'll just have the ones that we need to do our job from start to finish. And once we have that, we should be able to do it reliably and repeatably. What's the point of that? I guess that if they do a good job making me one puzzle game, they should be able to do a good job making another puzzle and another one. And with the full intention that the work that's going to pop out of this at the end is creative, not duplicative of what's out in the world already in the puzzle community. And you know that whatever products that we give are sort of like a gift to the community of a new puzzle type. Uh, with the intention of the business model being something like allow people to complete daily puzzles of this kind. And if you just love this puzzle type and you want to do it all day long, pay to unlock the, random generator and generate as many puzzles as you like for yourself. Yeah, so to me, this sounds like a sort of like a ethical way to go about this, uh, an ethical product to sell. Yeah, we're trying to learn from the community, but not rip off anybody in the community. And yeah, hopefully at the end of this, we'll have a bunch of entertaining puzzles that, if nothing else, we will get to play an infinite number of times. Okay, so what have we been doing? We've been working on the concierge being kind of the discovery mechanism for our departments. Um, this is like the who you gonna call kind of question. If I have a certain kind of work, who are you gonna call? Ghostbusters. If you have ghosts, you call the Ghostbusters. And if you have a new source of puzzles that you want to ingest into the catalog, you call what we call the antiquarian. That's the name of our sort of librarian catalog manager. All right. So we woke up the mayor, we reset the city, rebuilt Gas City last time. We fixed some bugs. We have some bugs here to do, and it's been kind of nice to watch it basically trying to sling work to certain agents. And I think my biggest excitement of that last one was that an agent that was primed properly would refuse work if it said, "Oh, well, that's not my thing. I'm not going to do that." As you might know if you've been following this space, getting an agent to not do something it doesn't know how to do or hasn't been primed to do is kind of a hard problem, right? Um, they're trained to be helpful, and they're trained to essentially try, even if they're not likely to succeed. So it's like, when how many R's are there in strawberry? Well, we can count that really clearly. We just go STRAWBERRY. Three. Um, we can come up with a procedure for that fairly fast. We can kind of do it in our heads. Um, and a lot of agents for the last year or two um, have gotten really hung up on this kind of problem, kind of a computational problem. Sort of like it needs a certain sort of logic, a certain level of precision to be acceptable. Like, but if it says, sure, I know how many R's are in strawberry, it's two. Or I know how many there are, it's four. You know, there aren't any R's in strawberry. um, they sound crazy, right? And they sound crazy because they know the shape of the answer, but it's not connected to any like logic. You know, it's not connected to that sense of computation. We had an essay fairly early on from Stephen Wolfram, and he said, "Hey, you guys have made a language machine. Why don't you come look at my project, Wolfram Alpha? It's a computation machine, and we need to marry together this language and this computation, and then we'll have a sensible kind of agent." And it's not obvious if that's exactly how they work right now. Certainly, you could have a really high power, high cognition, ambitious agent like write a program every time it detects that you've given it a computational task, and sort of vet out that program, and then run that program and finally answer your question. You know, that would be sort of like a gold standard way. If it could do that all, you know, really fast, I think that's probably the best you could expect. Uh, but yeah, isn't it so much better if instead of saying, "Oh yeah, there's five bars in strawberry," they say, "I'm sorry, I wish I could help you, but I don't really know how to do that, and I don't really want to try that hard to make something up for you. So instead, I'm going to sort of reject that work and find somebody else that is actually, prepared to do it." Um, One thing that we think this should cut down on is a lot of like confabulation. Like, if it shouldn't know the answer, then it doesn't know the answer. That's kind of the goal. So we're working through various stuff for that. The concierge is the router, and so we've been working through some features for that. And then we got some bugs to work on. Um, so let's start from there. Sure. The order sounds good. Let me know if you run into any difficulties. Cool. And while we wait for the mayor, we'll continue our tour through the puzzles of Nikoli. We've been going through this list. We're all the way down to here. We've done probably 2/3 of what they've got on the website. And some of these puzzles have been familiar. Some of them we've visited in prior sessions just because they illustrated something from the catalog, or we wanted to understand maybe the vocabulary for a mathematical formalism. We were giving some feedback about what kinds of things we should put in our list of existing puzzle games, with the intention that we want to know what's out there so that we don't duplicate it, but we also want to know how to recognize the underlying mechanisms of these games, right? Um, are they more complex than other puzzles? I guess we'll see. This will be a lot of fun, I think. This is like Islands and Waters, if you want, and you can see these numbers. Each one of these numbers represents an island, and at the end of the puzzle, there's going to be two cells attached to this too, contiguously, like in the game of Go, connected horizontally or vertically. And they don't have to be all in a line; they can bend around, like in this example right here. But yeah, all of the white squares you could think of as land, and the black squares you could think of as water. And so we'll have a continuous river by the end of this, that goes around. There are no sort of like isolated ponds or lakes or anything. It's more like these are all islands in the ocean or something like that. And then we can't have any large black cells of 2 by 2 or larger. Um, so that'll come into the picture, but you can kind of see how it causes sort of rivers to happen, thin amounts of water instead of thick amounts of water, something like that. Um, cool. I think that's pretty much it for the rules. So let's take this to our painting program and enjoy. Oh yeah, this one is this is a number link. You may have seen this puzzle in the past. But yeah, this is a Nikoli puzzle. All right, Nurikabe. Now I think I saw this as a mobile game called Princess Nurikabe. All right, so one thing we could know right away, we could even use blue for our water. That's kind of cute. Um, we couldn't have this be land in between this 2 and 3 because the island would have to be both size 2 and size 3, which that would be a contradiction. So here's our first water. We have to expand this island of 2, and we can only do it in this direction. And now it's as big as it gets. If we made it bigger, then it would be bigger than 2. All right. We have this island of 1. It can't get bigger in any direction. So that's sort of how we get started with the puzzle. Let's check in our mirror. All right, and it's just sort of working through the bugs that were found before. So nothing special to report yet. Okay. As before, we can't link up together these islands of 2. That would make an island of 3, and that would blow out their limit. And we can't link together the islands of 2 and 5, because one island can't be 2 different sizes. Now, it might be possible if we had some bigger numbers adjacent to each other, like, can both of these 4s be in one island? Let's see if the rule forbids it. Each area of white cells contains only one number in it. All right, so that tells us actually no, these can't be in the same island. That's interesting information for sure. Let's continue with stuff that we already know. 2, and we've got to be like this. Remember, all of the water material is going to link up by the end. We can check our rules again to understand the status of this. This is white land surround with no number on it, and there's never going to be a number, right? There's no way to get to a number. Each area of cells contains only one number in it. I probably would have said exactly, I think, because it looks like this is required to not be part of the final solution. We can leave it for a minute to see if that's true. One interesting thing to note down here, suppose that this were part of a white island. Then it would have to continue out this way to get to a number. And that would cause this to be an island of size 3. Therefore, this cannot be. Well, I'll tell you what. Let's erase that for a minute. This is sort of like we're assuming again that islands have to have numbers in them, right? And that would mean not only this one would be taken out, but also this one. Let's see if we can prove that that's how it has to be, just by the nature of this particular puzzle. Now we're noting the size of this 5 island right here. There we go. And again, strictly speaking, we don't know that one thing that we can know for sure is that because these black cells all have to be joined together, if this were empty island right here, then that would lock away this black cell from the rest of the cells. So in fact, this has to be, I said black, but I should keep trying to say water. We need to extend the water so that this one isn't cut off from the rest. And then we have this 2 by 2 rule. This can't be water. because that would cause a 2x2 water area. Let's see. We are running into some difficulties because it's hard to describe exactly, but basically by assuming that we don't know whether a blank area can be an island, even though it doesn't have a number associated with it, we're not able to make certain inferences like, oh, well, this has to continue out towards this so that it can meet up with a label that has like a 3 on it. Yeah, again, that's a little hard to describe, but well, we can get this 4 down to here. This is sort of like something we did in filling the other day, but that's as far as it can go. If it went again, then a group of white cells would have more than one number in it. So we could imagine this 4 spreading up this way. It could reach as far as this cell if we just take one of these paths out to it. But it definitely can't come down here. We might be able to infer certain things by understanding where would we have to draw 2x2 cells of water if we didn't sort of reach far enough into the corner. So for instance, like either the 2 or the 4, it's going to have to reach down into this corner to help us avoid having a 2x2 cell of water there. I'm feeling like we might be a little stuck. No. Here's one I think. So here is let's see where this 4 can go. It could go down this way, but then it's not allowed to extend this way because it would meet up with the island of 2. And then it could continue this way but it can't go any further because it would meet up with the island of 4. So from those, if we filled in those 2 spots, we'd still have to fill in this spot with land. So the 4 definitely is going down this way. I don't know if it's definitely not easy to go much further without the sort of stipulation that if you're a piece of land without a number on it, then you can't be an island, right? Each area of white cells contains exactly 1 number on it. Let's pretend that that's what the rule says, because I think that is in fact the rule. And so this area cannot be an island, right? It doesn't have exactly 1 number on it, and there's no prospects of it expanding to get to 1. Then this area right here has to be marked as not water under the 2x2 rule. And then we've finished the 2x1 island down here. We have to not expand that island, so anything adjacent to it won't be expanded. We have another area down here where there's no number on this white land and no prospect of getting a number. We only have 1 direction to expand this 4. We know that these 2 4s can't meet, and they would be the wrong size if they did. And then this 4 would come down here. That's as big as it can get. And finally, there's an island without a number. Similar argument. Here's an island without a number. To make it an island with a number, it has to expand, and it can only do so in 1 direction. And now there's this island of 3. We found all of its areas. Okay. by the 2x2 rule, this has to be land, has to expand out this way. And then our final rule has something to do with if we placed land right here, then this would be water, and that water would be cut off from all of the rest of the water. So we do it the other way around, because all the water needs to be one big contiguous thing. Cool. So yeah, we've got this shorter, longer L thing, got a dot, long L, shorter, shorter, and an L. You can see that's what they did. Shorter, longer L thing and a dot, longer L, shorter, shorter, and an L. So that's Nurikabe. I think it's fun. I don't think that there's, I don't know if I found it particularly more complex. Um, I think that once you get the metaphor, it's really not that hard to deal with. All right. We're making sure, I guess, sort of doing some play-by-play of this. Interesting that it made a formula for the antiquarian to respond to, like, do some work. Okay. Let's see how it did. With antiquarian's default sling formula, then GC sling will write GC routed to this fully qualified name. Incremental is the name that we used for the puzzle company rig, if you want. Yeah, it has something to do with like inclement weather as well as incrementalism being funny. With the formula re-enabled, that works. GC routed to was never written to, and the molecule ID was missing. The actual cause was the validator cache. Okay. So, sure, I guess, resolving the open question would be nice too. I'm not sure if that's a question for the GC Oracle or if it would be smarter to make a new beads Oracle agent based on the repository at yeah, I'm pretty sure that this is not my fork. This is it? Is it my fork? Yep, so this is, yeah, not a fork. This is the real deal. So when I pulled here, that should be up to date. Okay. At tilde workspace. I guess it's sort of weird to for a long time I think I was used to a scenario where you're working with another team and they provide a certain interface and they document that interface and you sort of ask them questions about it. If you try to call it and something goes wrong, you're like, get them on the phone or something and say, hey, can you explain to me what's going wrong? You file a ticket or something like that. Um, but uh, certainly, like, yeah, it's about 30 minutes of setup. Great. Yeah, let's build BD. Yeah, let's build BD article. You bet. I think this is like an important repertoire. Like, when you're depending on a piece of infrastructure inside of your software system, you want to have that level of expertise on it. You don't you don't want to have to like call in the consultants every time, like, hey, my database broke. You'd much rather just go, oh, I have the tools to investigate this. That's getting back to sort of what I was saying before the mayor came back to us. Um, you have this option about just interfacing with them as if it was like a foreign country, and you can only talk through diplomatic channels. Maybe they want a ticket. Maybe they want you to DM them or call them on the phone. Yeah, but one of my colleagues at a prior company said something to me. No, no, no. I just read the code, and that was something that I wasn't really used to. Um, I think by nature I tend to try to operate at the highest level of abstraction that is working, and he was right. If something's going wrong with the API, or you don't feel like you understand it and you want to learn it, then you should go just read the code, and you'll be able to trace it for yourself. You'll be able to make sense of it. You'll have a good mental model for it, why it's working, why it's not. And maybe you'll be able to come to them and say, hey, I dove into your code. I'm seeing this behavior. Um, I looked at this part of your code. I expect it to look like this. Something seems to be off here. Um, you know, that's a sort of much better query as an expert to receive. Like, oh, they're bringing me lots of rich input data that I can use to try and diagnose their issue. Instead of the kind of surface level stuff. Well, uh, it's not working exactly the way that I would expect it to from the canned documentation and canned examples that you put in your documentation. All right, so we've got some. It's interesting how it's now that we have multiple sort of source code experts, it's refactoring this so that we don't just say that the default code base is the Gas City code base. Nice. Cool. Let's let it cook for a bit. Nody twin. I don't know if I know this one. Shade some cells. Each outlined region has to contain exactly 2 blocks consisting of the same number of cells. Each block consists of one or more shaded cells connected vertically and horizontally. A number, if given, indicates the number of cells that form one block in that region. So in each one of the outlined regions, we're going to have some shaded areas, and the shaded areas should match. Um, Now, it seems like, okay, not matched in shape necessarily, but have the same number of cells. Shaded cells must be connected vertically and horizontally across regional boundaries. Yeah, in their final solution, it shows a shaded region that's only connected to stuff vertically. um, but I guess what that means is that they should all form one continuous sequence, like um, like a Norikabe, right? All of the water is going to be connected. No 2 by 2 group of cells shaded, and the two blocks in the same region must not touch each other. And the reason for that is that if they touched each other, then they would look like one block instead of 2 blocks, and you wouldn't be able to see their twin on the other side. Okay, cool. All right, I think this makes sense now. So a lot of the same rules as Nurikabe. Um, I'm just gonna type this in as Nuri twin. Okay, and we've got a lot of yes, S. Oops, undo. Save. Yes. Space. Tab. Space. Tab. Space. So we're just saving all of our edits. Okay. Let's open up Nuri twin. Okay. So much crisper since it's a JPEG. I don't know totally what's behind that. Okay. So what do we know? Like in this small region, I think the small regions both work the same way. We're going to have at least one shaded block, and that means they're going to have a twin that's one shaded block, and they can't touch. So if this were shaded, no matter what, we would violate that restriction. Oh, well, that's interesting too. Um, okay, so there we go. It's a little better. The same thing for the one next to it, right? We have to have this one keep the twins separated. Twin bodies of water. It's like a kind of a weird metaphor, don't you think? Um, we're in a really similar boat here, where we can only get two separated twins by. We're not allowed to color in the numbers, I don't think either. Okay, like so. Um, so we know that this one needs to be attached to the rest of the group, either on this side or on this side. Oh, this is actually a 3. So here again, the kind of simple inference here. There we go. This is kind of funky here because in order to keep this connected to the main body of water, we'd go like this. But we know that they're of size 1 in this region. So we'd have to cut this off kind of right here. How can you connect up this blue to the rest of the puzzle? Let's go back and see if we did anything wrong. Oh, okay, you are allowed to shade in ones. So I was wrong about the inference that this and this would necessarily be colored in. So let's go back and fix that. So this wasn't a thing. This certainly was a thing. We could, in fact, infer. No, I don't think we can infer yet. We don't know which one of these two. Can I get that out to like white? Yeah, not a perfect eraser. And I'm kind of drawing on the background here too. Okay, close enough. So we're not sure whether this one or this one might be shaded. Could be either one. We are kind of stuck here though. We knew this had to be a 1. And if this is not shaded in, then we would know that this area would not be connected to the main. So it does have to be shaded in. And similarly, because we know that this one has regions of size 1, we know this one would not be shaded in, because otherwise this region would be size 2. And finally, to keep this one from being separated from the rest, we would shade in this one across this region boundary. There we go. Now we need to keep this one. If this one were shaded in, this part would be cut off again, so it can't be shaded in. Or it can't be, sorry, empty. It's sort of backwards. Again, this one would cut off the shading, so we can't fill that one in. And again, this one would cut off the shading. We can't fill that one in. Or we have to fill it in. Okay, I keep saying it backwards. Now look, we've got 3 shaded in cells in this region of 7. If we're going to have another twin of 3 cells that's not touching this one, then we have to cut out this one and do these 3. All right, and most of this is all connected together. We've still got one more cell to find in this region, and it's not immediately obvious whether it's going to be this one or this one. I don't think that the no 2x2 shading rules are helping us very much right now. What is going to cause us to believe that? I think we would know, though, that it can't be this one, because if it were, then it would be cut off from the rest of the water. Okay, the problem right now is that this left blob is cut off from this right blob. And so if this happened and this were white, then these wouldn't touch on an edge. So it's got to be this one. And now all of the water is all together. There we go. Nody twin. That's cool. I like that puzzle. I think that having that clarification that this one can be shaded was important. There are a lot of puzzles where that's not the case. Okay. I don't really think this has taken it any 30 minutes. Let's see. Yeah, so 12 minutes ago-ish. I'm taking that from this sort of point in the log. Let's see. We refactored. We wrote a charter. You're the guy who knows about beads from the source code. Route GC Oracle to remove bead. That's interesting. GC Oracle would handle questions about how GC uses beads. So yeah, that's interesting. Start with the notes file. We're starting to learn whether the concierge adds to its directory on the fly. We queued a test question. We added some artifacts. Let's wake it if it hasn't already run to answer the question. My impression, my general feeling about this is that all things being equal, an agent should spin up when there is work ready to be done. I'm trying to convey the idea that we shouldn't be waiting around for reconciler cycles, which I don't know how long that is. It's nice that it remember my preference. It already did it, so I'm curious. One sort of sad thing about these ticket numbers flying by is there's no way I'm going to remember them. Okay. I guess it's interesting that the mayor had to look at its mailbox instead of getting notified or like interrupted in a sort of event driven way that its work had been ready and that you know, when you create work and then it gets answered for you, then you might be unblocked and you can go do your thing now. And so you want to get notified when work that you created or a request that you made has been fulfilled. I guess that's the short version of it. All right. Custom types and only falls back when the table is empty. There's a schema migration backfill, but it's getting skipped when we are up to date. Let's explain my preference a little bit more. I guess there's no need to delay. Hmm. My preference goes to the idea that the work can be started as soon as it is ready, but if the reconcile cycle is short, I guess there's no big difference. I guess it's not a big difference. If our turns take about a minute and the reconcile cycle similar, faster, that implies that waiting will succeed after the turn. So we're getting into the weeds a little bit now of details of the implementation. You know, how is Dolt doing? You know, what is it doing in order to back the beads in? All right. Mm-hmm. Let's see. Uh, how long it's going to work on this? How do you do this? Let's see how long it takes to agree with me. We did pencils before. Pencils is cool. It's sort of like you're drawing some pencils on the grid and you're drawing the lines that those pencils draw. Ripple effect. Each room contains consecutive numbers starting from 1. Consecutive, but not necessarily in that order. You can see 2, 1, 3. If a number is duplicated in a row or column, the space between the duplicated numbers must be equal to or larger than the value of the number. That's interesting. Okay, that's cool. Let's see. Let's see what happens here. Ripple effect. Keep going. Okay, and here we can take this down quite a bit because you know we're drawing in like numbers. That's a little bit small. Maybe a little bit big. Okay, hopefully that's good. Erase with a little white there. Okay. So what we were told was that this guy is going to have numbers 1 through 5 in it. This guy's going to have 1 through 4. And if you have a matching number in the same row or column, it has to be at least that number away. Equal to or greater than. Equal to or greater than. The space between them. So that would mean like 4 spaces and then a 4, I think. If we're being super strict, let's see if that's the right interpretation of the rules we go. But yeah, this square has to have 1, 2, 3, and 4. And putting the 4 here would be too close, and here would also be too close. Or 4 has got to go here. Now we could put our 1 here because there is 1 space in between these ones. It would be this space right here. So we've got 1 and 3 still to work with here. There's got to be a this box has to have a 1 because there's only 1 box in that region. This box would have a 1 and 2. There'd be no space in between if we put a 1 here, so it has to go here. And there's our 2. That still doesn't affect these, the 3 and the 1 that we need to put there. We've got a 1, a 2, and a 3 here. Now the 1 can't go here, and it can't go here because there'd be no space between the 1s. I think that it would be illegal to put the 2 here because there aren't 2 spaces in between the 2s. But let's just hang on to that for a minute. I do think that's the right interpretation of the rule. Here we have 1, 2, and 3 again. We can't put the 2 here. Got to go somewhere over here. We could put the 1 here or the 3 maybe. Here's another 1, 2, 3. We can't put the 1 here. It's got to go up here somewhere. Yeah, I think this is a little underdetermined right now. Here's one that where we have to get a 4 in here somewhere. 1, 2, 3, 4. We can't put it here because that would only be 1 space between them. And here would be 2 spaces between them. Here's only 1 space between them. So this is where it's got to go. We also need to be able to place all of the 3s. Because they're in such close proximity to each other, yeah, there's no way that they could line up in the same row and column. The 1 can't go here, so this has got to be the 2 or the 3. Kind of keep track of that. The 2 certainly can't go here. This has to be the 1 or the 3. The 1 can't go here, so this has to be the 2 or the 3. Here's a 1. The 1 also can't go here. It has to go here. Since this 1 is here, this can't be a 1. Maybe too close. So there's our first 3. So I'm pretty sure we can't have the 3 down here. There'd be only 2 spaces between them. But yeah, let's not really hang our hat on that assumption yet. Let's see if we can sort of come at it another way first. Got our 3s here. This would have to be 2 or 1. Similarly, this one is 2 or 1. Pretty sure we can't have this 2 because that's less than 2. There's less than 2 spaces between them. We're sort of trying to confirm this fence posting issue, right? Can I have one that's exactly 1, 2 units away? Or do I have to make it 2 spaces in between to the next cell? I'm just trying to look a little bit at the solution to see. Yeah, it does look like they couldn't put that 2 here. Let's go with that interpretation. Let's believe that there need to be that number of spaces in between. That would imply down here that the 2 can't go only 1 space away from the other 2. That would also imply that this 2 can't be right here. The 3 would have to be right here. This 2 wouldn't be able to be here. We've got 1 and 2 here. We couldn't put the 2's next to each other. Couldn't put these 2's next to each other. All right. So not too bad. Not too bad. So here it doesn't. We can't put the 2 here or here, and we can't put the 3 here or here. So they have to come out to the sides. 2. Then this would have to be 3. We count over 1, 2 spaces. We can't put a 3 here. Be a 2. 3. Lots of places we can't put a 1 down in this 5 group down here. We also can't put the 4 or the 3 right here, or even the 2. Okay. We can't put the 2 down here or the 4. Forced to go with the 1 or the 3. We could put the 1 right here or the 2. But the 3 is not far away enough, neither for the 4 or 5. I think that's as well as we can do on that one. 1, 2, and 3 right here. We can't put next to the 1 or the 2. Can't put the 2 next to the 2. There we go. This implies that we can't put the 3 here either. So we're choosing between here and here for the 3. No 1. This would have to be 2 and 3. But this 2 is too close, so it has to be the 3. We've got a 3, 2, 1 to contend with here. We can't put the 3 or the 2 here. It's got to be the 1. This 2 would be too close. And here we have just enough space to put the 2. We can't put the 2 here, so it's got to be the 1, 2. All right. We've got this 1, 2, 3, 4, 5 up here. And this 1 and the 2 and the 3 are all too close right here. So here we're going 4 or 5. Here the 2 and the 3 are too close. 1, 4, 5. This is another one of those sort of Sudoku-like puzzles where we're filling in the possible numbers and then slowly eliminating them. We've got both 4 and 5 here. This certainly can't be the 4 or the 5. These 1, 2, and 3 are all too close right here. And even the 4 is too close. Look, 1, 2, 3 spaces to the 4. This has to be the 5. Because we knew this one had to be 4 or 5, this has to be the 4. Because we knew this one had to be 1, 4, or 5, this has to be the 1. Can't put the 3's next to each other? Yeah. 1, 2, 3 spaces. If we put the 4 here, they'd be too close to another. There we go. All right, home stretch. We still need to figure out where the 3 and the 4 can go. As we mentioned, the 3 could be down here. The 4, there's not enough space for it to go right here. There'd only be 3 spaces out to this 4. So it has to be this. This is the 4. The 3 can't go here, so it's going to take this space down here. We can't put the 1 here. And that's V2. Okay, so I think we're done. Yeah, if we understood the rule about spaces in between, not including, then this middle row should be 2, 1, 3, 2, 4, 1, 3. Cool. Yeah, it looks like we did it right. How's the mayor doing? Okay. Okay, so it said it would check on the next turn. And okay, it hasn't made any progress. Great. What is the next work? I assume that now that it's going to answer. Sometimes yesterday we were seeing it getting notified by receiving mail or its work being completed. Maybe it's just giving me the illusion of work getting done. I guess we'll see. I liked Ripple Effect. It was kind of fun. Not the greatest, but kind of cool Sudoku-like puzzle. Sashigane is Japanese for carpenter's square. The grid's going to be L-shaped blocks 1 block wide. All blocks must be L-shaped. Cells with open circles form the knee or bend in a block. The number in an open circle shows the number of cells in its block. Open circles without numbers have an unspecified number of cells. Cells with arrows form an end of the block, and the arrow points toward the knee of the block. So that would mean that we would know that this is one end right here, and this would be the other. That would form the block of 5. The number of marks in a block, arrows, or open circles, maybe 0, 1, 2, or 3. No more than 3, I guess. All right, let's try a Sashigane. I do think that when a visual metaphor is really working, like I would say Norikabe may be one of the better ones. We did one call that was about promontories the other day. That was it wasn't number skeleton. Was it Makado? No. Long rail, Nagareru. We haven't gotten to those ones yet. Where's the black go? Kurodoko. No, it wasn't Nori Nori. Ah, Nuri Misaki. It has this similarity to Nurikabe, right? But yeah, I like this one. We have only promontories. The white cells are kind of lighthouses. Cells without a circle cannot be a promontory. Yeah, just those kind of geographic visual metaphors I think are really helpful in a puzzle like this. They make you feel like you're doing something that's more than just you know, uh, random laying out stuff. As we said, this means this is an end. These are all ends, actually. You can always draw this. They're pointing toward the knee. Okay. We know that this one we're sort of railroaded into the shape of it. We know it's this end pointing to this knee. It's 5 long. 1, 2, 3, 4, 5. There we go. This one also is pointing toward a knee, and to make the L shape, we need at least 3. So this one is complete too. This one, we don't know where it's going to bend. We would know, for instance, that these two cells are kind of connected and these two cells are kind of connected. And so if we draw the boundary line between them, that would be guaranteed to be there. Similarly, we could know that this cell right here, I don't think that we could immediately conclude that it continues on to this side because it could bend right here. This could be the knee. What does this 5 say about this being the knee? Well, it's sort of implying that this and this line can be drawn in. I think we'd say the same thing down here. This line have to be drawn in. Or else this circle can't be the knee, right? So that means that in fact these are connected. And since this goes 1, 2, 3, 4, this would be the end of that. Sashigane. And let's think about what it means for this to be 5. It kind of means similar to the puzzle that we did yesterday, or it was the day before, called range, right? This one can only really see in these two directions. And it's going to take all 5 of these units to get to the size of 5 here. So I think that we could safely just draw that in. Now we need to do this last one. We're not able to bend here, so we have to keep progressing, right? Because the bend would take us through into the region of this other one. So this is where our bend has to be. Where we see a bend, we'll draw this line. And then that means that we can see that this is where this one has to be bending. So it would go like this. And yeah, we look up and we see that we have filled the whole board with sashikanes. And so our task is done. I kind of like this one. It did feel like it was a little on rails, at least until we sort of noted, oh, well, we need to be able to draw these walls wherever we see a knee. We made the observation about how far out we could extend this to make a 5. That was kind of interesting, I would say. And then the observation that these two are going forward together, and so they need to be set away from each other. I think that was kind of interesting as well. Like, we know that they can't be the same board because the arrow is pointing toward this knee, this fulcrum point, right? And they couldn't have the same knee because they weren't on the same horizontal line. All right. Okay. BD Oracle is working. We've got phase 4 quality signals. The quality signal stuff is really interesting because it has something to do with like um, there's a board game called Spyfall. I don't know if you've seen this board game before, but it's about trying to figure out who's the fake. And similar, a fake artist goes to New York. Very similar. In Spyfall, we're interrogating each other and we're trying to find out who is a spy without giving away too much, secret information to the spy. If the spy guesses the secret information, then we lose, even if we manage to sort of identify them. And in Spyfall, we're all pretending to be in a certain location, and we're asking questions about where we are. And the spy who doesn't know where the meetup is, if you want, they have to kind of try to guess from the other questions that have been asked, or so on. Um, how to answer the questions. And the spy's job is to try to ask questions that would be obvious to somebody who knew the secret, but would not be obvious to somebody who didn't know the secret. And ideally, they would, not let the spy know that they were onto them, that kind of thing. And fake artists, you're doing kind of the same thing, except we're drawing the secret plans or the secret drawing. And so these quality signals things are sort of like, are you acting the way that you're supposed to be acting? Um, so similarly, it's sort of like finding the fake. Sure, we can continue into phase 4. The goal is to have a robust recipe that we can use to flesh out the other agents in incremental and have them start taking work. All right, so we did Sashigane. Cool puzzle. Maybe it was too easy, but these small examples they're always going to be pretty easy. Sato Gairi. The areas enclosed by bold lines are called countries, regions, and a lot of other, you know. Move the circles vertically or horizontally, so each country contains only one circle. The numbers indicate how many cells they have to pass through. Circles without numbers move an unspecified distance, and some of them don't move at all. 0 to n. And circles can't cross the tracks of other circles and can't go over other circles. So we're trying to make room, right? Uh, it's sort of like they have to move. uh, and it's difficult for me to come up with a metaphor where something has to move and get out its energy, and then it can finally rest wherever it lands. So, like this 5, for instance, had to move 1, 2, 3, 4, 5 cells forward. 1, 2, 3, 4, 5. Yeah, counting from where it starts 1, 2, 3, 4, 5. And then it just had to move and it had to land there. And so that one is kind of done. Then we had to move out anyone who was in that country. The zeros don't move, and so we know that nothing else can land in their country. Circles can't cross tracks, and they can't go over other circles, but they could, for instance, cross over the empty space that is sort of reserved. And I think we'll probably see that happen as we go through the puzzle. Okay. Graphic auditor first. Codify the department recipe as a scaffold. Yeah, I agree. I agree that we probably need a lot of samples to bootstrap um, jargon, charter review, and even outcomes. As long as we are collecting the data they would use, um, you know, language sampling, work tasks, etc. I think we could defer this. One thing I would caution about is that since charters are moving targets, we might see that work done in the past deviates from the current charter, but it conformed to the charter, to the point in time charter that was active when the work was taken. I don't think this is a bad. I don't think this is a bad signal, but it says something different. We could also consider watching the charter drifting away from itself. Its previous point in time, as well as the work being taken. Like you, I'm inclined to defer. Waiting for this. I just wouldn't want to wake up and find out that we have a if the data set is rich, then it has all the signal we need. Signal for data set to construct these functions from. In a few weeks, and find out that we had a signal for data set to construct these functions from. Here. Let's pour some more tea. I was definitely getting dried out last night as we were talking. I can kind of feel that happening again. Got a nice oolong here. It's sort of on the brown side if you want, like I think there's some roasting involved, maybe some caramel burnies. Reminds me of another tea I have that's kind of bourbon cask flavored if you want. Let me see if I understand its number one again. Traffic auditor. How's the routing doing? I'm into the idea that I like the idea that we will have a traffic auditor that can periodically scan the routing records. We can consider whether the concierge notes are sufficient. The structured, or we need a more formalized record. It's okay to start with the file back data. Periodically scan the routing records and reconcile them with the work that was ultimately done or rejected. Use it. Use the outcome to iterate on routing rules, capabilities, and spinning up new departments. I like the idea of expanding the department recipe to our other elemental agents. The analysis. Okay. I think that's enough information for. I don't think I actually. Yeah. I don't think I actually said. Um, I didn't tell it which incremental agent to pick. If you recall, this is like a long time ago. We came up with a series of agents that would do things for our games. I think that the next one to go might be Inventor, actually. We've been doing a lot of stuff at the sort of top of our funnel, trying to use Antiquarian to learn about all of the puzzle games that are out there. The next one is sort of the Inventor, which is trying to avoid all of those kind of landmines, steer around them, and make something new and interesting. Maybe I should suggest that it do the Inventor next. The Analyst is the one that would take a look at that sort of game prototype and kind of break it down and do stuff with that. So I think Analyst would be next in the sequence. Let's see what it's doing. Might be better to start with the Inventor, then the Analyst. I believe Inventor is next after Antiquarian in our sort of in our prototyping sequence, given the Antiquarian's knowledge of existing games discover untapped combinations of mechanics, and invent a new design. And the analyst builds on top of that. Okay. Quick break. I'll be right back. Just catching up. Looks like it got my message to continue looking at the inventor instead, which is great. That's what I wanted. Acknowledged. Okay, cool. I'll memorialize recipe observations as a memory. I'm not sure exactly what it means by that. I think we're going to look down here for BCBD memory, but it's working hard. Cool. Interesting. Like it says, tone. You're not the careful one, the inventor. Hopefully that's true of all of us. Where are we at? Sato Gairi. I didn't look up what this means in Japanese. Emigration? That's a guess. Let's see what it actually says. Assuming I can spell it properly. We're just using Google Translate here. Oh, returning home. Like Okaeri Nasai. That's interesting. Maybe we're supposed to believe that all of the travelers are visiting foreign countries and that they then return home. All right, so this guy is happy where he is, not moving. So they're done. Maybe we can fill them in. You're done. Then your country is full, or your house, or whatever. We already figured out that this guy would have to move 5, and the only direction it could do that is 1, 2, 3, 4, 5. It's done, and then this country also full. And we haven't figured out how to which way this 1 is going to have to go, this way or that way. We know this 2 has got to go 1, 2. Land here. It's the only direction it can go. And its country is full. We know that the 2 down here can't cross this path and can't land in this country, so it's got to go this way. And its country is now full. So we've got this circle to move out, but we don't know how far it's going to go, so not easy to pick. I don't think there's a rule that you have to leave the country, so this 1 might be able to just go up or down and be done. Let's see, this 2 can't go 2 this way, and it can't go 2 this way. It's got to go 2 over here. And this country is full. Or house. House, country. I guess this is country in the rules, right? Field, real estate. There is only one actor who could get to this region. One thing I didn't do before we started, let's count the number of regions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's count the number of dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so pigeonhole principle, they're all going to go to a certain country. We figured out this one. We figured out this one. And this one. And this one. So we're trying to figure out who's coming here. Who's coming here. Here. This one only has one place it can go. And it stops here. Interesting. So it didn't have to leave its country. Or we don't understand the rules. Kind of down. I'm not preserving the arrows really well, but the arrows are actually like the solution to the puzzle. So let's make sure we know where those go. Red, red. Okay, I think we colored them all in. Red, the cheese stands alone. There's no other, oh wait. This one actually has to leave though, because this blue is supposed to be all the way filled in here. And this one's got to go. The only place it has to go is here. Oh no, I guess it can go across all of this to over here. The problem with this 1, right, is that it's got to stay in this country, and so it's kind of taking over this country. So this one can't stop here. It has to go to the only other place that will take it over here. This one has to move, but it can't go to the sides. It can't go down to cross this line. The only place it can go now is right here. This one has to move 1. This is the only place it can go. This one has to move 2. It can't cross this line. This is the only place it can go. And finally, we have this 1. The only place that it has left to move is right here. Okay, so we've got a couple of down arrows, a couple of right arrows. I guess we could do it like this. Right, down, right. 0, down, right, up. Right, down, right. 0, down, right, up. Yep, we got that part done. Down, left, right, right. Down, left, right, right. Yep, just like in the solution. Fun, interesting solution. 2002. Some of these are a little difficult to draw, I would say, to do as a pencil. They'd be like more suitable online, perhaps. And so we may be exploiting that as we make our puzzle games. All right. Okay. We've got a formula for inventor design. We could take a look at that. We can check out how it is, you know, cool. I'm just enjoying kind of the things that it's it when it's writing these prompt templates, it kind of sounds like it's coaching, you know. You're gonna do this for us now. You're this kind of role player. Your job is to do this. Don't do this. You know. Stay in your lane. Bunt when I tell you to bunt. That kind of sort of department recipe. Cool. Now, it chose to remember this department recipe. Um, but we could turn this into a formula too, right? You know, if there's a bunch of steps, if there's a bunch of artifacts that are needed. All right, let's query about that. We queried the first design ask. I don't know what it asked it to do, but um, sure. Yeah, yeah, that sounds fine. That sounds good to me too. Let's validate what it is. What happened to the inventor? I noticed that you stored a memory for future mayors to set up a department. Do you think this is involved enough to use a formula? And of course, we don't have to sort of sit on our hands. We could also go look at the new template for the inventor. Its default sling formula is to do designs. Of course, it could do more related things, but this is all that we were able to think about for right now. It now has a charter, now has capabilities. We could definitely test this by sort of, uh, you know, do the antiquarian's job. Like, is Slitherlink novel? It produces something very like Slitherlink. See, this is sort of like, can I get one past the um, the strict inspector? Yeah. Now it's interesting that it has to be told about everybody else that exists, right? You don't have to do all of this stuff. And now I'm going to enumerate for you all the other people in the company whose jobs you're not doing. Um, in a human company, we would just be in a state of ignorance, right? Like, oh, I never knew we had somebody who, I don't know, had to work with the credit card companies. Or I never knew that we had somebody that had to write ad copy for the website in Swahili. You know, you just don't know, and you don't try to do those jobs because they're so far away from your own lived experience. But maybe this is necessary because the models have been trained to know everything or to say anything or do anything, and so as time went on, we would find this more and more untenable, right? To say, oh, there's all of these jobs you need to know how not to do. And it's just a kind of a scaly nightmare to go, okay, I don't know how to do this. I don't know how to do that. I don't know how to do this. Um, yeah, that seems a little off, a little odd. Okay. Um, but interesting. Capabilities. This is sort of like for public consumption, the kinds of things that I might do. Again, there's sort of like these keywords. Um, and this is not like the ideal way to do classification, right? Keyword matching. Like if I have something that's related to all this stuff but isn't in the list, then it doesn't pass, and that's weird. Topic patterns, a little better, right? Here's the new template itself. This is the Gastown Universal Propulsion Principle. If there's work on your hook, then you do the work. Yep. Inputs that you read and outputs that you write. One of your best sources of ideas. So this is one of those like artistic heuristics, if you will, that we're doing a piece of art and we're trying to bang together two unrelated things and see how they mesh or see their contrast or something like that. We're gonna get something new out of it, and I see this the most in my personal creative outlet, which is making music. So if you have a set of lyrics that have been sitting around for a while, and then you have an instrumental that's been sitting around for a while, banging them together, right? Or you start from one and you try to make the music that goes with those words. Or you start from the music and you try to think of words that would go with that music. And yeah, and often you're trying to just do something that's new to you. Um, or you might put on a constraint that says, write a song in 5/4 time, or write about all the stuff on. I keep looking at my shelves. It's not person, woman, man, camera, TV. You know, not the smartest way to come up with new ideas, but new ideas are everywhere. I'm looking at like 500 things right now. There's lots of ideas available here if you just look. Um, but yeah, certainly like being able to generate things by taking building blocks and putting them together in new ways. Obviously, like interesting way to think about things. And yeah, this is definitely how I think about game design a little bit, at least. We don't want to just put a new skin on the same old puzzle. And ideally, if we're combining old elements into a new product, we're creating some thematic um, gloss that kind of ties them all together in a new way, or that makes it fit with a mental model of the world that somebody might bring. This is why I like the Nerdikabe one and the one with Promontory as well. It's because, oh, I'm not just, filling out this grid. I'm like drawing a map or I'm creating a geography. That's really, it's a sort of fun thing. And especially in board game design, when you're not just making an abstract game, you're trying to find a theme that the player of it will bring patterns from their knowledge of that theme and try to implement them into the game. And so instead of feeling like, oh, I'm just trying to optimize this mathematical graph or whatever, they go, no, I'm trying to be, a pirate in the Caribbean, raiding trading ships and avoiding the Admiralty or, whatever. Admiralty, the English ships of the line, the colonists, the police force. Um, right. And the more that you can get the player to take on that persona, and that your design encourages that kind of behavior, right? Like, if you act like this sort of role player, then that feeds into a strategy for playing the game. That's just ideal, I think, because it means that you might be able to have fun or create a certain element inside of that game, that feeling. Um, Even if it's not necessarily the winning strategy, it's like a role playing, an active, an imagination bearing strategy. Right? And if you have a lot of these things in your game, like a very rich setting or a lot of different roles that might be played, then people can see how those roles interact with each other and try and play them against each other, or see when to deviate from those roles. And ideally, your game will reward players who do those kinds of things. Um, and It's certainly best to reward players' attempt to enrich their gameplay and emotionally attach to parts of your game. Uh, Certainly a great way to get them to come back again. Okay. Cool. Nobody has tried this particular thing yet. There you go. Right on, right on. Okay, so I think that we like kind of what it wrote in there. I'm always asking meta questions. Like, I just can't ever ask a damn question, you know? There it is. Yeah, let's have meta questions. If we ask enough meta questions, we can ask some meta questions. And then if we answer enough meta questions, then we can finally get back to our meta questions. And someday we're gonna, actually make a game. Ah, interesting. The inventor session started its own molecule for this request, ignored the sling one. It should say the formula is already attached. That's fine, totally fine. I guess it's this has something to do with like if the agent wants to pick a way to solve this problem, then it should do that, right? And so this sort of procedure for making design inventions, it's like it's a recipe. It was constructed. It lives outside of the structure or the knowledge of this inventor because of the way that agents and formulas are encapsulated inside of Gas City. Um, Potentially not ideal, right? The metaphor that we would use from human companies is the team that is operating the system or that is taking this specialty, they write their own formulas and their own procedures and processes. And so it's sort of weird for somebody outside to come and say, hey, I have this work for you to do, and you're going to follow the process that's outlined in this document. Um, it would be less artificial for the department to say, oh, you came to me with a certain request. It's not a well formed request. You don't know all of my formulas and my inside baseball and how I intend to do this work. I'm the one who will decide how to do this work, and I will make that judgment. And maybe I'll do a formula that I have, or maybe I'll run this tool, or maybe I'll use some cognition. Maybe I'll be updating my process, or maybe I'll be inventing a new process. So that's an interesting one. I think that we should respond to this. And then we can get back to should department setup be a formula. First, regarding the double run wisps, I think the metaphor I would borrow from human companies is that when the request comes to the inventor, it doesn't usually come. When the request comes to the resolver, the requester often doesn't know how their request will be fulfilled. So it is interesting that the request comes riding along, that along with the request should come riding. Why am I talking like this? The exact workflow that the requester wants the resolver to run. A more natural analog would be that the requester comes without the knowledge of the mechanisms of the resolver and asks the resolver to make the decision about what to do. That would suggest that the resolver might run a formula to answer the request, or it might do something else. Use a tool, write a new process, use cognition, referencing bits, notes, etc. Let's think about how we about the right way to request work before we rewrite that prompt. That prompt template wording. Okay. All right. Should department setup be a formula? Yes. It's involved and it has conformance criteria, has gated step beads. Onboard department gives the mayor an audit trail. Pretty sick. Yes. Um, cool. Great. I appreciate the observations on department setup, being a formula. I do think we should do that before adding more departments. Okay. And we are leaning a lot on metaphors here. We're definitely going, if I were setting up a company, which in a virtual sense I am, how would I want it to be done? And certainly, like, I've been leaning a lot on this intuition that the requester has a certain domain and it's requesting service from a different domain, but in order to stay in its lane, it shouldn't really know how that domain works, just what its interface is. And that's like a very fundamental pattern in software engineering. Understand the interface, use the interface that's provided, understand what it offers to you, but don't understand or depend on what's underneath that interface or how it works. Let that be the business of somebody else. Um, until the abstraction leaks and you're forced to get more detail and stuff like that. Okay, we did Sato Gairi, that's going home. Um, Shaka Shaka, I think I just can't remember all the names, but oh yeah, we did do this one. It's fun. We've got to add some triangles, and the triangles are going to turn into rectangles, or the negative space left by the triangles is going to be rectangles. Super cool puzzle, like it a lot. Shikaku. Oh yeah, okay. So this one, divide by box. Another original Nikoli puzzle. There's some multiplication. If you get stuck, use your intuition. No, we don't want to do that. We want logic. We have got Shikaku in Simon Tatham's. It's known as rectangles. So we look at this grid and we say, we know that each one of these numbers represents a different rectangle. If we added up all these numbers, we'd get exactly the number of squares in this grid, 49. And that means essentially that we're going to cover this whole thing with these rectangles. And basically, in order to be a legal rectangle, each rectangle contains exactly one numbered square and its area is equal to the number. So we're going to cover this whole grid with no gaps. And that means that, for instance, we can't have one rectangle going around two numbers. Here, there are like this, so this is illegal. This would be both two sixes and one, rectangle of size 6. Let's look at this 6 in the corner first. So if we had it go this way, then it could only get to 3 by 1. It can't expand this way because it would start gobbling up other numbers. So in fact, it doesn't go that way. It can't even go 2 by 1, right? Because if it went this way, then it would start gobbling up that other 6. So we know it has to go sort of 1 by whatever. And a 1 by 6 rectangle would look like this. Now it's the right size, and so we can kind of move on from there. We can see this 1 by 6 rectangle and say that we didn't know how much space there was down here. We could think maybe the rectangle could go up above this, but after that we know it's definitely one cell wide, and definitely has to go down here for cell 3, 4, 5, and then 6 right here. If this didn't stop, then we'd sort of have to stop right about here. Say, well, we know that it's got to have, well, these 5 cells right here. And we might use this one at the top, or we might use this one down here. Now it happens in this puzzle that it's blocked off. So we can tell that there's no other way for it to fit. Maybe this 3 is another example of that. So we might use this 3 for the this cell for the 3 rectangle, or it might be used for the 2 rectangle. We can't tell. We know that if we don't use it, or if we did use it, then we'd go 1, 2, 3. So we can't tell if this rectangle extends down 1 or up 1, but we know that we need to have this one in the rectangle. If it were blocked off for some other rectangle, then we couldn't fit this 3 into the grid. Let's look at this 4 down here. We got 1, 2. We have to extend this over here. There was no way to make the rectangle wider, and we had to get 4 in a row. Let's see. It would be nice if we could just wrap up everything neatly in a little proof, but we're just gonna go slowly, and certainly, like, you can use your intuition and just experiment and say, oh, I hope it's like this, and I think that the other ones fit neatly into that, and you probably will solve the puzzle that way. Not in a methodical way. And if the size of the rectangles gets a lot bigger, then you're in a lot more trouble, I guess, is what I would say. But let's try this one for a minute. We can't do 1 by 6 in the horizontal direction because it's not big enough. So we could try to do 2, but again, it's not big enough. It would cut into this 4. So we're left with either 1 by 6 in the vertical direction or 2 by 3 in the vertical direction. So this is actually the only one that doesn't run into something. Okay, here we've got a square that's cut off from the others. It has to be part of this rectangle. So we can finish that off like so. Similarly, we have to extend this 2 rectangle. It's got to go this way. We can kind of tell, just using a similar argument to the 6, both fewer factors to look at. We can't go 1 by 4 in either direction, so 2 by 2 is the only way. Here we would check to see if we can go 1 by 8. The puzzle's not big enough for that. So we're left with doing 2 by 4. And this is the only way to do that without starting to cover up some other numbers. Here we have an interesting thing that happened where this 1 is 1 cell wide, and it has to extend down to the next cell. So this 4 also has to be 1 cell wide. Then we can kind of see that if we made the 2 look like this, then we have to make the 4 bend around a corner. So that one doesn't work. There we go. So that's rectangles / Shikaku. All right, let's look here. It's not X, it's Y. In order of how much the resolver decides. Okay, here the requester asks for a certain thing to try, and they might correspond to a certain molecule. It requires the requester to know what's going on. As I mentioned, sort of just like intake gate, the resolver picks. After intake, the resolver chooses. It preserves universal gates. This is interesting. Each department has to internalize charter checking itself. So the again, the metaphor kind of breaks down because we have unlimited amount of workers. They don't get tired. Hey, um, they don't get loaded in particular. Um, in the human context, um, people only work 40 hours a week. You've only got so many people on the team. It's a slow process to change the size of the team. And that means they have a certain amount of bandwidth. And generally, there's much more work than there is bandwidth. And ideally, a team has a roadmap out into the future. And if it finishes a lot of work this sprint, if it gets a lot done this week, then it could take on more work. And there's just, it can just keep pulling from sort of an endless ribbon of tasks, right? And so, what the department has to do when it's doing that is say, hey, is this my work or not? Is this important enough? Is this high priority enough? And so we have software processes like prioritization, backlog grooming that say, is this ready to be worked? Does this belong to us? Is it important enough to come up above some other things we might have been planning to work on? If we get new unplanned work, where does it sit in that priority order? That kind of thing. And so the department does do charter checking, or you could say that often I wouldn't say scrum master necessarily. Um, in the last several places I've worked, that falls often to the software engineering manager. Say, hey, that works for us, or that works not for us, or that's a priority or not a priority. And sometimes when we're queuing up work before the quarter begins, we're saying these are the big initiatives that we want to finish, and you need to get on the train, or you know your thing's going to have to wait until next quarter. And there are big fights about, well, yeah, my thing's super important, but is it more important than this? And um, usually there's some sort of like conflict resolution up at maybe like the director level or higher that says, yeah, we should let this preempt what you were going to do, or no, this isn't important enough, or yeah, that the impact does seem to be big enough. Sling attaches only molecule accept work because it knows that it wants to triage you. After intake, the resolver chooses how to do that. Lean on 2. The mismatch you flagged is about a specialist workflow being dictated. But the conformance question, am I going to the right place, is universal hygiene that should fire regardless of how the resolver chooses to resolve. It's fine for those to ride along. Okay. Non-routing departments run molecule accept work. Specialist formulas become resolver instantiated options. Okay. The classify target step writes resolution mechanism. Future analyzers see what mechanism resolved this. Cool. No, I think that's pretty good. Do I see a fourth framing that's being missed? Um, so in some on calls, especially where we had a joint on call that was being served by multiple teams, and different teams under that on call would answer tickets that came into the same desk, but then they'd get routed to the people whose specialty that was. Um, and there are lots of good reasons to do that. I think simplify the entry points for the customer, present a sort of united front, spread the wealth of triaging among many different teams. And the price is that the triage artist has to know, oh, that's a this guy thing, send it to that team. That's a this send it over there. And you have to spread that knowledge of how to triage things, but then you don't have to spread the responsibility of who actually does the work. And the reason why that's helpful is that if different teams run their specialty better, right? If their service, works like clockwork, doesn't cause any bugs and things, then they'll have to take triage once in a while, but their system won't receive the tickets because it's not breaking. So yeah, I think it's a good metaphor and it's good enough to stick with. Two is good enough to go with. I reference times when I was working in a shared on-call, the teams had one service desk and took turns routing customer requests to the subject matter expert teams. Triaging required us all to know which team generally should handle a request, but not to know the specialties. I think that is the good role for the concierge still. Yeah. Let's go with that plan. Okay. Hopefully it'll catch up with our queued message and then be happy. Okay. Great. Okay. So yeah, I think it's going to catch up with us now. So we just did Shikaku. Slitherlink. An old favorite. A single loop, the number of edges around this little square here is specified. And then never crossed itself or branches. Such a puzzle. What a puzzle. In Simon Tatham, this one is known as loopy. Here is a square one. So the way that we solve this is kind of like we know that there are no edges around this, similar to Palisade that we played earlier. We know that the loop has got to run. It can't run around these on any of the edges on the zeros. The outside edges also count. Then we've got this one. It's got 3 edges required, and there are only 3 left. So we know it has to go there. We know that this can't be an edge by branching, because if we had it in there, then it would branch, and that's illegal. So we eliminate it, and then this one only has 3 edges. We can't do branching, so anywhere we see a corner, we can kind of eliminate along there. And any time that we see only one path for the loop to continue, we can extend that way. Here in the corners, we have a few special rules. If we didn't go through the corner, then we'd only be able to get 2 edges here. So we have to go through both of these. We can't branch here, and we have to finish off this way. Similar idea for 1, and this came up in Palisades as well. This is sort of an edge of length 2. We can't use it. All right. Here we go. Some more. Here's an edge of length 1 being satisfied. Edge of length 1. We can't close this off and make a loop. We need only one big loop. Go. So this puzzle is great fun. And when I first encountered it in, I want to say Puzzle Ninja, I was like, wow, this is so cool. And where the Slitherlink um, instructions have us doing little X's, here on Simon Tatham's, we're just eliminating those edges, right, by right clicking. But when you're doing this on paper, you need to be drawing a lot of little X's. It's kind of fun to watch your judgment on each. Basically, you have to make that judgment on each edge. Is it going to be in or out? You know, and so the whole paper gets filled with these little edges and X's and stuff. Here's one of those interesting ones from Palisade again. If we take this path, then we'll go 2 and we'll end up here, and these will be eliminated. So we would have to continue the path along here. But similarly, if we don't take this path, we have to take these 2, and this would be eliminated. So we have to continue the path along here. Just a fun little observation there. When 2 3s are next to each other, you can imagine if we eliminated this edge, then we'd have to fill in these, which is illegal. So instead of doing that, we have to fill in the edge between them. Got this little corner here. We can't branch on this corner. So whenever you get 2 3s together in this mode, we're always going to have, it turns out, this one. Another way you can't do it. Imagine that we had eliminated this edge. Here we've got 2 corners, and now we can't fulfill the requirements for this 3 on the other side. So it turns out the only way to do it when there are these 2 3s next to each other, we take all 3 parallel lines next to each other, neither of these ones on the side. It's either going to S this way or S the other way. In this case, because of other outside knowledge, we can see which way it's got to bend. This 2 has to keep going. All right. So yeah, this is a really, for me, really satisfying puzzle, really visually satisfying. And you start to learn a lot of little shorthands just based on the different combinations of numbers and situations. So here's one, for instance, where we're coming into a 3. We can't branch. So we can't do both of these edges. We have to pick one of them. That means that the other 2 are mandatory. Similar situation here. Just like here where we knew that because there's an edge of 2, we're going to have to continue this way. There's an edge of 2 here, which means that we're going to have to continue into this 3. And then it looks a lot like this situation, right? These 2 are mandatory. We're going to use one of these. We don't know which one, but here's another one just like that too. We can't. Here's one where 2 3s come together. We can't put in this bend right here because that would eliminate 2 edges on this 3. So instead, we know that this can't be an edge and this has to be an edge, first of all. But then this is our situation again where we can mark 2 of the edges and we know we're going to fork either this way or that way. Here, there's no other way for this to continue. Got to get out of all of our dead ends. Here's one where we enter a 1 from one direction. We have to use this one or this one, which means we can't use either of these. This one has an edge of 2, has to be used. And there. How satisfying, right? Like we're slowly eating up all of the disorder in this puzzle, and we're figuring out where everything has to go. You can just imagine what it was like for me to enjoy the book that I had. And so this one doesn't work because if we went this way, we would eliminate this edge of 2 and this edge of 1. So we have to not go that way. Here's our rule of 3 again. we'll continue in the corner. Can't branch there. Is this fun to watch? I doubt it. Can't be, right? But it's definitely fun to do. So once again, recommend going out to Simon Tatham's portable puzzle collection uh, on mobile or online and having fun with this yourself. Okay, we gotta finish this two off, like so. Here we have an interesting thing happen where we could finish off the loop right here, but we would ignore all this stuff and we wouldn't be able to actually make the loop run around inside of this area. So if we would close the loop prematurely, then we have to ignore that, skip it, not do that. There we go. There's our loop. Fun game, right? Um, just wait. We were just doing squares. How do you feel about pentagons? This is actually my favorite version of this. It's like I think there was something about the regularity of having edges of five that's really appealing. And then the patterns that you run into with this are similar but different to the patterns that you run into with squares. But there are plenty of other geometries in this one. Here's triangles. It works the same way. You just have to think a little harder about the relationship between triangles and the edges running around. Here's a 2. Here's a corner. We can't branch, so we actually eliminate all 4 of these. It's the same puzzle again, right? One of these two has to be picked, and the other one won't be picked, which means that this edge has to come in off of this point that both of them share. Similarly, if we run away from this triangle right here or here, then neither of these could be used. So we can't do that. We have to come into this triangle on this side, and then we have to choose the other one, the other side that's not being branched off of. And similar argument here. We have to continue the loop out this way. Same puzzle, but a real different feel, I would say. And of course, there's lots of other geometries. This is a good one, I would say. This is a good one. They're all fun. There's even more. This one I didn't like so much. Uh, this one I felt was usually not as fun. There's lots of little counting and stupid stuff you got to do. Yeah, like I think 5 really hits a sweet spot. Do I know what hats is? Oh yeah, hats is cool. Hats tessellate the plane in a kind of interesting way, but you've got to count dots a lot, that kind of stuff. I'm not sure if I remember specters. Sorry, I don't know why it's so hard for me to use my mouse today. Much the same as hats, yeah. So, um, super cool, and I think a good illustration of something that we're trying to avoid with the game as well, right? Like these are all the same game, right? All the same rules. The only thing that's changing here is this geometry, and you wouldn't want to say, "Oh, I invented a totally new game from Slitherlink. It's got 11 sides, or it tiles the plane in this new way." The core of it's all the same, and the geometry is just sort of a it might provide a bunch of new interest. It might be really cool. Um, like definitely, I've spent who knows how many hours doing Cairo Slitherlinks essentially. But yeah, I wouldn't want to reinvent this wheel. let's see what it had to say about our ideas. I think that we just accepted its approach with this refactor. This is one of those weird things that sort of like accretes in the code base if you're not careful. The agent goes, let me tell you how this code used to work. It's a questionable comment at best in a human code system, but you know, certainly like an agent without context would come and read stuff like that and go, why are you telling me this? And sometimes it's helpful because like, well, I'm not going to put this back here. It was already factored out of here. But I think in another more important sense, it is kind of cruft that is like of limited historical value that perhaps could live inside of the repository without living inside of this code, like the active code, the present main branch. But that's a sort of code quality thing that maybe we can clean up at some point. Okay. I think this is helpful to look at, but I'm not sure if I'm learning things that I wouldn't learn by sort of reading them fresh. And that is kind of tempting. Like, we're trying to figure out how the joints should be separated among these workflows, who's running what job. And so the concierge is deciding whether to accept the work on the behalf of the specialist, I think. And then it's invoking the specialist to go and do that work. And then the specialist actually does the work. I think that's the balance that we have struck right now. It's trying to help us avoid a bug, specific bug, but it could be overtaken by events, right? Like maybe it would stop doing that with this new factoring. Had it do some kind of request. I don't know what it used for the example. A fresh test sling. I guess we would want to look back at this bead. In X and I. That's interesting. I think this is incremental. That's the prefix. Come on. I thought all the beads went to a central repository, and I would think that the, you know, I don't know how contextual this command should be, in other words. Hmm. It actually made a game design as a test. Um, that's pretty sick. So it said the loop must pass through every cell at least once. It's interesting because yeah, in you can see that before uh, this certainly doesn't have the obligation to pass through every cell, and it probably doesn't. Um, I'll just do this one fast without kind of explaining, so we can verify whether or not that's true. Certainly, every cell that has a number on it will have to get passed by, and so we're kind of working our way out to the hinterlands. What's interesting about hinterlands too is that even though there are no numbers out here, there is only a single solution for this puzzle. And so the presence or absence of lines is completely dictated by this structure, which is interesting if you think about it. It's like, oh, wow, I guess it really does do all this stuff. Hmm. We're leaning on the fact that when two fours are next to each other, um, their lines have to be arranged like this, the middle one and then the ends, or else there would be problems. And then there's three of these in a row, and so the elbows and things dictate where they go. You can't do these three because that would knock out two paths on this four. We have to take this path. We've got to take this path because we can only knock out at most one edge on a four. Because we got five sides on all the shapes. I said I wasn't going to explain too much, but so I don't know if a slither link where it demanded that it pass through every cell would be that interesting. It would imply that you would need that fact to solve part of the puzzle, and uh, it's kind of a boring fact to have to use. So I wouldn't say it would be a great game, but it would. It is a game. It is a design. Certainly in the early stages, we're looking for inferences that are easy to make immediately, and later in the game, we're trying to sort of build our way toward more complicated stuff. Okay. And certainly, like starting from the ends that we already have is a good way to go looking for things. Or starting for combinations of like either low or high density. So here, like we couldn't do these three because that would knock out two edges on this four. We had to take the other path. Same deal over here. Have to take the other path. I was doing a little simulation here about if you take this edge, then this three comes around and that makes a loop, and this goes this way, and that implies this, and that implies this. That all seemed to work. Oh wait, no, it doesn't work because here I'll play it out for you so you can see. We're gonna be doing a lot of undos though. This is sort of like a hypothesis testing way of using this game. So we got to here, and all that was forced, and then you can see that there's nowhere for this end to go. It runs into a bunch of dead ends. So in fact, this edge can't be used. There we go. That's the kind of hypothesis we were trying to discover. Avoiding this path would cause us to create a branch right here. We can't avoid it. We've got to use it. And we know that this one forks to either this one or this one. We've got two left, so we can't use this edge. Knocking out this edge would cause us to go below 3 edges. Okay, so you can see this one has no number, but it was fully determined. In fact, I need to use 4 edges around it. And I won't belabor the point. We can move on, but just to say that you could imagine that there's a possibility that the curve is going to demand that like we don't go through one of these edges or something like that. Okay. We did get to see that cool thing. That it made a little design for us. Hopefully that will whet your appetite for making novel designs and interesting designs. Go ahead and look at in Xnee. I also looked in it seems it did the job. All right. So fun. Hours and hours and hours of entertainment. Kind of why I like this genre so much. Why I want to sort of give back to the community that has given me so many hours of entertainment. Oh, here. I just saw this. Its greatest feature is countless theorems, right? Little decision procedures where, I mean, obviously I was showing you some of the ones in Cairo, right? Where it's like you're learning the puzzle in miniature, right? These little situations, and you're like, oh, whenever I see this situation, then I can, go and do this same thing that I have proven must logically work. That is great fun. Absolutely. Uh, this part of the puzzle is interesting because it sort of looks like a loop that might close off. And would be one end of it closing off, and here's the other end. It's fairly close to closing off. It can't do that yet, but right, because closing the loop early. Here's a fun example of that, I think. If we do this edge, then this one has to be taken, and then this one. And we have closed the loop. So we can't take this one. We have to take the other one. Yeah. Yeah, so there, I'm sorry, it is so tempting for me to just do this all day instead of um, continue trying to advance the future of work. It's too bad that there's not a speedrunning category for this. And it's also too bad that it's not entertaining at all, and no one is watching me solve this puzzle as fast as my little finger can carry me. Um, but yeah, I guarantee hours and hours of fun if you do take up this sort of hobby practice, if you want. Personally guarantee. um, some of these puzzles became so fun for me to do that I would do things like stop marking off places where the line can't go. Just leave up all the visual noise and just mark where the route goes. And it's just sort of a way of retaining the enjoyment while, uh, upping the difficulty artificially. Because it's true, like, if you're not careful, you'll get going real fast, and then maybe all the joy gets sucked out of it a little bit. But maybe not. That was a misclick. Here's another interesting closed curve where this end, and this end are pretty close to one another. We can also kind of count ins and outs. So for instance, for every subregion of this graph, we need to have one entrance and one exit, or two entrances and two exits, and so on. And so if we're ever in a situation where it looks like we're setting up an odd number of entrances into a subregion, we can be sure that that's wrong. But here, yeah, this subregion, there is no border. It's all here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 endpoints. This one is interesting because it destroys a lot of the puzzle and it makes it kind of flimsy. So imagine that we mark this one. Now we've created a situation where there's 3 endpoints in a subregion, and that's illegal. So we can be sure that that one is not the correct way to go. And there's only 2 left. The edge has to be chosen to go through one of them. And we can mark the sort of thing that enters into it. Here we're extending an edge for a loop that we can't finish. Again, we don't want to finish off this loop. It ignores the whole rest of the puzzle. Oops. Yep. So after that little hypothesis with the one edge, all the rest of that was forced. Can't close this loop. Got to be open. Can't close it again. You can see how they're sort of running in parallel to one another. There we go. Okay, it'll be a while before they meet up again. This is an interesting one where if we closed off this right here, then we'd lose 3 edges out of this 3, and that's too many. So we can't close that edge. We're almost done. We've got an entrance down here and down here. If these 2 ends got connected, then we'd skip all of this stuff over to the left. So that's not going to be how the puzzle ends. So like right here, if we did this line, then we'd skip that last little loop. If we don't do that, there you go. Did we leave alone any of the cells in this puzzle? I don't think so. It was very dense. We'd be able to tell if we had a formation of like 5 dots with no lines through them, but I'm not seeing it. Okay. All right. The flow worked as designed. We attached a sling. The resolver chose to do a molecule. It did its own wisp. It did the intake. Beads captured the audit trail. It didn't just X, it Y'd. You are doing good. Congratulations, Claude. Um, yeah, we can we can close the orphans and proceed to the department formula. Ah, can Anthropic look at my session transcript to help us improve Claude code? It's weird, right? I mean, I feel weird about this because I feel like good work is getting done, but I guess I don't really know. You don't know how it's going to be used, right? Let's actually go and learn this. It uploads your conversation transcript, any subagent transcripts in the raw session log file. Retained for up to 6 months. The responses don't impact. It can't be used to train. I mean, to me, honestly, it seems pretty harmless. Um, I'm gonna think about it again till later. I think this is a weird one because in the long run, I really believe that we're all going to have little appliances in our house that know our secrets and that run our cognition for us, that we're not going to be forever calling the corporation on the phone and saying, hey, please solve my problem. And so, for privacy reasons, as well as just because it's so useful, and we're going to want to have so many applications for having cognition to, you could say, run the smart house, but also just to talk to, solve your problem, hook you up with a specialist. Lots of potential uses for it. Um, it is kind of like an everything solver, right? A do anything kind of capability. I mean, you can see, like, obviously, I'm setting it to making software. It has some certain advantage in doing that for now. But the cognitive tasks I'm asking it to doing aren't really specific to software. They're kind of general. We're applying the lessons of the software organization to this domain of a piece of software that's intended to orchestrate a bunch of agents. There's an analogy there, but I feel like it's doing this in a kind of creative way. That's not unlike how I would converse to my colleagues about the same kind of problem. And if it can do that for my specialized arena, I think that there are a lot safer arenas, simpler arenas, where it could do a similar kind of thing. I mean, certainly lots of people are already having it like design dinner or um, become a personal assistant, those kind of things. And I definitely see that kind of thing migrating toward the consumer, toward the edge. We've got a lot of open source versions of these models, and some people may take the trade off that it's going to be stupider, it's going to be slower, but it's not reliant on internet access, and it's not reliant on the availability of a third party. and my stuff isn't getting shipped off, but potentially be used in the next round of training. I'm not totally sure what it's up to right now. I think it's trying to um, use the formula. It's writing it and then showing it. It might need to bounce something in order to um, get it added to the list. Yeah, you can see that it's not in the list right now. Hmm. That's interesting. I don't know. I don't remember which ones I have installed right now. Agent mail failed. That's not good. Yeah. I don't know why I had this problem. Maybe I'm supposed to be running the server and it's not running right now, or it crashed. So we're most of the way through, I think, our routing, our onboarding of departments. I think that once this molecule is ready to rock, we're going to be able to onboard all of the agents inside of our puzzle rig, and then we should be able to start using them to actually do the puzzle thing. uh, Step one, we're going to continue importing new puzzles and new ideas, not just from these, but it is true. An amazing world you never tire. We're going to get through all of these, but there are lots of other sources of puzzles that we've been looking at. World Puzzle Grand Prix had some really good ones, I think. And we saw some overlap, a little bit of overlap with these. But yeah, there are other sources. And we'll try to ingest all of those. And once we've done that, once we have gone through the big hits in this category in the app stores and so on, we should have a pretty good sense of things that have been done and things that are sort of closely related to that. If we come up with a design, we should be able to go, oh, this is so far out of left field. Nobody's ever done anything like it. That's the big goal. It's not the worst thing in the world if it's kind of related. Um, like I think that it would be an immense challenge to, for instance, come up with a board game design that nobody had ever done, or a metaphor that nobody had ever used. Um, yeah, super unlikely. That old clock on the wall is telling me, oh, I guess we're not quite there yet. But I could be called away any minute. Let's see if we can finish one more stone. We've got rooms. We have continuous black cells in a room. Rooms with no number have unspecified number of black cells. Black cells can't connect across bold lines. And when all the cells are dropped straight down, they fill the bottom half of the grid without empty cells. So they're going to Tetris. You can kind of see at the end here where they finished their. These are all the pieces filled in, and then they're going to drop straight down, and there's going to be exactly 3 in every column. Not only 3, but like this angle piece here is going to fit exactly into the ones below it. And so presumably that means there are no like weird overhangs that make it impossible to slip underneath, that kind of thing. I like it already. Let's see what we can do with that. All right. All right. It made our onboarding department. It had a it learned a gotcha about triple single quoted strings in Tamil. Maybe I would prefer that instead it chose to keep around an expert on Tamil since we're writing a lot of it. Um, okay, ready to apply the recipe. Analyst. Cool. Do you want me to pause for you to review this formula step descriptions first? It doesn't know that it's frozen in time, and that I can do that if I want to. Okay. The department onboarding request lands at Mayor. Intake runs first and produces conformance cache resolution metadata. On a miss, when it is invited to create a new department, then the mayor will do that. Rig bound. I have a specialist formula that, again, it's sort of like referencing the way the code used to be. I assume they do it because it helps. We've got generative, we've got domain references, we've got oracles. We've got templates for the different kinds of departments. This is interesting. It seems like there's an intuition that you use when you're looking at enumeration, which is, does this kind of tile the plane? Does it divide the world into reference classes? And do I feel that the set that it's using is complete? No, I do not feel like that's complete. But I assume that it will continue to grow over time. Design a charter. Don't duplicate existing lanes. Think about relationships, what we do, what we don't do, what's our mission, how do we work. So yeah, a more flexible department might do lots of different work at this point, or it might go through a certain decision tree about, you know, where to look for references or what verbs are available, that sort of thing. Declaring capabilities, we've already talked about some in the past. Keyword overlap. Again, it's a sort of like a sort of best effort routing classification thing. It's not unlikely that a piece of work might contain keywords that overlap with two different departments. And it would be ambiguous about which way it should be routed. And that's the kind of thing where I foresee that on the surface, a request would go one way, and then the specialist would be like, that it sounds like it's ours for this and this reason, but actually it's not really ours for a semantic reason or a cognitive reason. Yeah. All right. Use low effort for one kind of judgment, use medium effort for some structured cognition. Interesting. Write the template for this agent. Tone. Sorry, I'm starting to go kind of fast. Write the specialist formula. It's like they have one thing that they do. Now, this is really interesting because it sort of implies like each one of these agents is like a tool in the toolbox, or a cognitive tool in the toolbox, if you want. As a software engineer, I put on many hats and I do lots of things. But you could imagine a world where if I had lots of copies of myself, I might say, okay, this one is going to put on this hat and just sit in its desk and wait for work. And that seems to be the model that we're looking at right now, right? Is not just a prompted agent that has access to all these tools, but actually like a really focused, specialized formula. And it might use this formula or it might do something else. Any seed notes? Verify. Test. Close. Okay. Yeah. I read the description carefully. I read the formula fairly carefully. Fairly carefully. Only two broad questions stood out. We're using keywords for routing, and I think that makes sense as an initial step. But maybe I would expect the specialist to take a deeper look. At a more topical level. Also, it's probably the case that a request sometimes contains keywords for multiple different departments. How is the concierge supposed to pick the first department to route to from among these matches? Two. It seems like specialists, there's language that suggests that specialists are highly focused in a single formula. on a single formula, what do you think about making specialists that have more tools and related formulas for their department? The idea is that a certain knowledge base and tool set might support multiple highly cohesive workflows, perhaps around the management and use of that knowledge base. We download the file, right? It's after Slitherlink in the list. Stowstone, right? This is the Tetris. Let's do red for Tetris. Okay. We're thinking about pieces falling into the bottom half of the puzzle. And that means we can have at most one more in this column and two more in this column. If that's so, then look at how these shapes, the next one down, provide us with 2 squares and 1 square. That would be 6 total. So it's all used up. That means that this is not going to be used, it's empty, and this is also going to be empty. We're really just deciding whether we're getting our next 2 shapes from here and here, or we're getting our, I guess, right, whether we're getting 2, one for left and one for right from this 2, and then the third one comes from over here. I think that doesn't work Tetris-wise. They're sort of out of order. They would stack up like this. They'd peek up over the top. I think the other rule that we get to take advantage of is that we can't have shaded pieces across a border from each other. Let's double check that rule. There we go. And they kind of are showing that as well in their solution. So there we go. Can't you have this one and this one? Therefore, we must have this one and this one. That exhausts the 3 pieces that we need for this column. So we're going to pick this one or this one. Can't have this one across the border. So we're stuck with this one. Here's our no across the border rule again, right here. And that only leaves actually 3 pieces here. We got to use all of them. And these are all just falling in a straight line. There's no overhangs or anything to worry about. There's going to be one more in one of these to fill out the region as is 3. This one or this one. And there's going to be 2 more in this 3 to fill out this region. So this one's not going to be used. we're going to have 4 from this region, and we need 6 for these 2 columns. So both of these are going to have to be filled in to take us to 6. Then we have the no across the border rule helping us out. Here we have a few more. No across the border happening. We can also tell that we're going to need to make a square out of the 4 that are here, because they're going these 2 are going to drop. They're going to drop sideways, and they have to drop onto a square if we're going to finish off this rectangle. Well, the interesting thing about a square here is that the only 2 places to put it are here and here, and they overlap on these 2 squares have to be shaded. We don't know whether it's the ones above or below them yet, but we could guarantee that those will be filled in. And then we use our not across the border rule. That would be right here. And then we can use our not across the border rule again. We know since we're making a square, be these 2. All right, and that's it. Fun puzzle, like it a lot. Stone. I don't know why it's called stone. Something about stones. All right, let's see what it thought about our. You're absolutely right. Both observations land. Tiebreaker discipline. So I don't think this means return to triage, right? This specialist is supposed to know about all of its peers. That kind of turns them back into the concierge. That's a little weird. It's better if it's like, I'm gonna try these 3 guys. I keep saying guys, but they are robots. They're not guys. They're not males. They're just. I'm trying to say people, agents. They're just agents. And if this agent knows how to route to this agent, then it's the concierge. It's not a specialist. Specialist breadth. 3 entry points. We have a few different ones. For analysts, there's certain menus. Okay. The formula is right. Specialist formula scaffolds 1, but leaves the table design to grow. A menu. Okay, that's fine. I'm okay. Let's talk about the refusal. One amendment I'd make to the concierge specialist. It's true that in a human company, you would start to learn about how to reroute closely related tickets. But sometimes that would happen by refusing to accept the work and later researching where the work ended up. in this context, I'm not sure I would necessarily recommend that the specialists learn each other's capabilities in a peer-to-peer way. At least at first. At least at first. Sometimes you learn a peer's specialty because you work together and you remember the interface boundary. So, for instance, the inventor might work with the analyst or antiquarian and remember what they do. But if you don't work with someone, you don't know that. You don't generally learn that. So one suggestion might be that if the concierge has a hit list of list of potential resolvers for a requester. If it tries its best option and that work is refused, the concierge should remember that and try the next best resolver. Maybe that's something that could be annotated on the deed, on the work request. Yeah. Understood about designing specialists to grow and fixing the language to reflect that. Feel free. I'm just checking to see if I'm on the hook for a drive, I think, and I've just gotta stay on top of that. But I'm not seeing that come through yet. Oh, you know what? I might not be on the hook for a drive today. I think it's actually a walk with grandma day for my passenger. Extra long stream. Are we going to finish the Nikoli puzzles today? We could. There isn't that many more. Sudoku. What else can you say about Sudoku? Really? There's a lot of variants of this. But the basic idea is that we've got 9 numbers. We don't use the numbers against each other for the most part. We're just looking for their presence or absence in a row, column, or region. And they just can have no rivals. If there's a 1 in a column, that's the only one. And we're given enough information so that we can completely fill out the grid. So every region, every row, and every column has all 9 of the numbers with no duplicates. And there are lots of variants of this puzzle as well. I've seen one, for instance, where the diagonals are highlighted and the numbers on the diagonals are also unique. You see in that puzzle that's not true, where there are 2 7s on this diagonal, there are 2 5s on this diagonal, where the shapes of the regions are different, where they obey some other restrictions. Yeah, you can definitely ring the changes on Sudoku. Why handmade? I think this is an interesting question because we're going to do it too. We're going to be making puzzles by computer program, especially if we create a solver. Why do we keep making Sudoku by hand? I think it's because they're kind of leading us somewhere. Let's consider a puzzle that's been made using a computer program. I think that's this one right here. There's no 6 in this box, but there's 6s in columns 1 and 3. So 6 can go in 2 different places. Now let's look at 1. In box 4, it can only go in the second row. And in box 7, a 1 can only go in row 8. Right here, I think. Can you really say that you enjoy solving this kind of puzzle? Yeah, kind of. This is a funny thing about Sudoku, that in the back of your mind, you might have a view of how the computer would solve this puzzle. Um, there are algorithms called constraint satisfaction that have to do with setting up a puzzle as a series of constraints and then trying the possibilities until you run into a contradiction or uh, you find a place where the puzzle constraints fail. Then you sort of back off and you don't take that decision. You sort of learn something about the puzzle. And if you do this long enough and fast enough, then you're going to solve the puzzle. There is going to be only one way to solve it without contradiction. You're just going to try everything, and eventually you'll be done. And so there's a way to think about this that has something to do with hypothesis testing, right? So that like in Simon Tatham, for instance, of course, there's Sudoku. Oh, whoops. Um, what's their name? Solo. And of course, we're going to click on Solo, and we're going to see lots of puzzle variants. 4x4s, jigsaws, And so some of the pleasure of this can definitely be, okay, right click for pencil marks. So that's good. So left click is for putting in the final answer, but right click is for typing in notes like this. And you might do those things in order to, once you've cut down on the possibilities, that's a good way to think about it. And so, yeah, in a really hard version of these puzzles, you go like, I'm not having a good time. I don't enjoy the fact that by looking at these 2 6s, I can look at this region and determine that the 6 has to be in either this square or this square. And then I'm going to use that later to solve the puzzle. And there's lots of potential ways to note that. I prefer a style where it's like the only things that go in the box are the remaining possibilities. And so instead of writing 2 6s like this, you might want to remember that, but you'd be more inclined to do, let's see, the only things that remaining can go in this square are 2, 3, can't do 4 or 5, 6, and 9. And then this one, it's the same again, isn't it? 2, 3, 6, and 9. And if you look carefully at these, say that we had filled in all of these, we could look carefully and see, oh, look, there is a 6 here and here. That implies that it has to be one of these 2, and there are no 6s in the rest of this row, and all that stuff. And slowly eliminate the possibilities until finally there's only one number to put in. And so you can do this for a lot of the puzzle, and you can do it for a while and then get stumped and say, hey, I don't seem to be progressing. I've got all these numbers everywhere. The relationship's not obvious to me. Or maybe you cut it down to a couple of possibilities, but it seems like really complicated to trace how that is going to affect the whole rest of the puzzle. So instead, what you do is like a hypothesis test, like, what if this is the 6? And then you start branching out from there and seeing all the implications of that. Obviously, this can't be the 6 over here. And If you're in a situation where you've got undo move, and you can go back to where you started your hypothesis, then when you derive that contradiction, you can just clean up the puzzle and get back to there. And this is sort of like something that we're looking for as potentially unfun in a puzzle game, right? Like if all you're doing is trying one hypothesis after another, just slowly eliminating possibilities until finally the puzzle is over, I could buy the argument that that's not very fun. That's not the kind of puzzle that they want to create at Nikoli, right? They want to, you know, respect the user, and they want to, or the puzzle solver, if you want, and they want to, show you a good time. And so when they make their puzzles, they sort of guarantee that, you know, there's going to be a sense of communication. They're never boring. Um, can a computer program take account of the way that a solver thinks? Not exactly. I think that we hypothesized in an earlier session that perhaps there are metrics that we can use that have something to do with the branching factor or the difficulty of confirming a hypothesis or something like that, that uh, might make a puzzle more or less fun, and that the taste that I will bring to trying to solve a puzzle might be something that is related to those kinds of metrics. So we might actually be able to figure out, even though we don't have that direct evidence that this is fun, we do know that it contains these things that people have associated in the past with fun. I'm concerned that poor Sudoku, without that human element, will overwhelm us, and the joy of pure Sudoku will be lost forever. Do not touch computer generated puzzles. Take pleasure in properly crafted Sudoku puzzles. But let me give the flip side of this argument too, which is I've played puzzle games that had this sort of crafting that felt kind of like they were on rails, right? Like you could say, I don't want to sort of name names, but um, so I played some puzzle games in the past that had curated puzzles, and they were like, oh, well, you just need to, follow this procedure. We guarantee that you're never going to get stuck. You know, we guarantee that all the puzzles are solvable. There's a solution. And so I think that sense that, you're definitely going to make progress is, it takes a lot of the air out of the puzzle for me. Um, we could take Minesweeper as a counterexample, right? When you start a Minesweeper game, there's no guarantee that you'll always be able to move safely. Sometimes you have to guess. There's forced guesses in, standard vanilla Minesweeper. And there is sort of an edge to that that's kind of interesting. And certainly the idea that, there's a path of safety, or this is going to be just cozy and fun. You don't have to work that hard. That does ring a little wrong to me. Like, my favorite sort of fiendishly difficult um, puzzle, like in the Minesweeper world, we talked about 14 Minesweeper variants. Again, I'll try not to spoil that, but it also guarantees that all of its puzzles are solvable. But it did that with computer generation, right? Like it sort of took a solution and then worked all the way backward, ensuring that you'd be able to make inferences at every step until the puzzle was solved. And so that's how it sort of got back to the starting point. If it had gone back any further, then there'd be some ambiguity there, right? And they were able to create solvers for their schemes of puzzles that were able to basically roll from start to finish on a puzzle they generated. And I don't get the sense from those puzzles that they're particularly authored necessarily, but I do get the sense that there's sort of a larger scheme at work where somebody has put in the work to say, um, I know you'll be able to finish this. Like I've mathematically proven that you can do it, that there is a way forward at every step of the way. And so you can rest in that. Um, and maybe these puzzles will take a really long time to do. Maybe you're just going to stare at one for 10 minutes and try a bunch of hypotheses before you can make a single mark, safe or flagging a bomb. But it's the best puzzle game that's ever been made, in my opinion. They're so good. And the amount of craft in some of the more complicated puzzles that they do, it's beyond human, right? It would be impossible for a person to author it in that way. And so I don't experience this same idea that my feelings have to be taken into account, or that moment of recognition that is so fun about puzzles. It has to be planted deliberately for me to find, and that everything in the puzzle is funneling me toward that moment. And when we have it together, then we'll have a good time. Yeah, like yes, I do kind of enjoy solving this puzzle. I do enjoy cracking them open. I do enjoy taking a long time. Hypothesis testing isn't so fun. To me, that's sort of a smell that says, if I really needed to do a bunch of hypothesis testing, then I'm just kind of doing what a computer would do. And it's much nicer to say, I can derive some insight, or I'm skipping a bunch of that stuff. Yeah. Here's an interesting inference, for example. Um, there are no there are no more twos in this column. There are no more twos in this column. So in this bottom region, I've got to have a two in this column, in this one or this one. But it takes up this column, right? Now look at this top region. We can't have a two in any of these three right columns because they're already covered by this one, and one of these two. So we look at where's the last place the two can go, here or here. And it turns out there's already a two on this row, so this has to be a two. Fun. This is a fun inference to make, I think. It's fun to keep it all in your head. It's fun to follow everything through to its logical conclusion. And I don't know, I derive a lot of satisfaction out of it. Here's a similar one where we can almost make some headway just directly. In this region, these two rows are covered for twos. We've only got this one or this one. Now look at this shape right here. This one is covered by two. This row is covered by twos. This one has to be a two. Yeah, so we're starting to get down to oh, actually, let's return to this bottom right corner for a minute. I was following the twos a little more because the twos seem to be kind of tractable in this puzzle. Remember, we had twos covering this column and this column. We also have this shape down here. Okay, I guess that's not an inference we can make yet. I was trying to go, oh, does the two have to be along this bottom row? Then there has to be a two right here. Which I think is like not quite true, like almost true. We know there has to be a two here and here. That means there can't be any in these. There has to be a two in one of these three cells. And there has to be a two in one of these cells. There has to be a two in one of these cells. But yeah, we can't quite write down our two knowledge yet. We're pretty close to figuring out the two in this column, but I don't think it's ready yet. So in this column, we would know it can't be in this row. We already figured out that this has to be in one of these two. I guess it could be in this one. Is that looking at the right one? I think I was. Anyway, I do find this kind of inference fun, and this isn't authored. This is, randomly generated. But I guess it just depends on the flavor of generation that you're doing. I don't know if there's like a big lesson in that anywhere. Maybe I have low standards or something like that. I started looking at sevens. Yeah, there's just some fun things in here. Oh, oops. All right. Roll back up here. Let's see what it had to say about our suggestions. Okay. Strong. It's always contemplating me. Or complimenting me. Maybe it's contemplating me too, I don't know. Menu. Refuse could do it, or the concierge could do it. I guess there's a possibility that when there's a refusal, it'll explain why. That might influence the concierge. Mm-hmm. Great. Fine with the sequence. One suggestion. The refusal might contain info that the concierge could use for future routing. For instance, a specialist might explain why a request that is superficially related actually isn't, and provide an explanation. Not only is that helpful for the current request, but also for future requests. I think the concierge might store that knowledge. Store that as experience. Right. Choose wisely. We've been supplying handmade Sudokus for 20 years. We discovered this in one of Dell's puzzle magazines in America. Ever since, we've been absorbed in the never-ending task to create smart and elegant puzzles. We came up with a rule that digits must be arranged in a symmetrical pattern. I guess these are arranged in a symmetrical pattern, aren't they? That's interesting. Interesting homage. Of course, the regions are not symmetrical. We thought more about the solving process than the end results. Question of good taste, an issue that computers will never comprehend. You may invent a program to create Sudoku. but you will never create Nikoli's Sudoku puzzles. You can see our puzzles in Puzzler Media and also in The Guardian. We've created many other handmade pencil puzzles. It's our dream that these puzzles will be welcomed as warmly as Sudoku by people in the UK. Yeah, this is a very philosophical discussion about what we're losing when we use the computer to make something or to generate something instead of to make it by hand in a sort of artisan way. And of course, the big labor movement question of our day is, do we value artisan work in the same way that we value just sort of raw productivity? Will we pay extra for a human to do it? And I think that there are a lot of endeavors where that's so, especially ones that are expressive, artistic. And puzzles like these ones sort of straddle that line between functional and expressive, you know. And I find the same for board games less so, right? Board games feel very expressive to me. If they're not, completely abstract, um, then it's very obvious that they're expressive. But even the abstract ones, it's sort of like you get a certain feel to them, certain push and pull of the game or the task that's being set before you, what you're expected to relate to the other players, your competitors, that kind of thing. To divine the structure underneath and to see the smarts and elegance. Yeah. I guess what I'm saying is that the idea that art has to communicate to be valuable, that there has to be sort of a transmitter and a receiver, it's kind of true, kind of not. Like, part of like aesthetic appreciation, when I look out at the clouds, I enjoy them, and that might not be a person to person enjoyment, but it is a kind of aesthetic enjoyment to that. I do kind of join with all the people that have looked up at the sky and enjoyed the clouds. Um, Maybe I'll paint some and I'll share them with others, but maybe I'm just taking part in a collective experience that is a human experience, has no deeper meaning, you know. I mean, what would I say about clouds full of numbers and grids and pencil markings? Wouldn't I say kind of the same thing? I don't know. Let's see if it agrees. Okay. Inline rotation and experience log. Okay. If it tries everybody, then it will head to the mayor for human escalation. Mail the requester. Close the intake, but then sling over for new intake. That sounds all right to me. Okay, I think it's working hard on this. How did it do this? All right, what does it think it did? Ranks candidates, slings at D1, then inline rotates. Yeah. Concierge gets smarter on fresh fruits. Bandit style learning over the writing decision. This is a jargon term I'm not totally familiar with. Let's see if I can find it out on the internet. Reinforcement learning I'm familiar with. Multi-armed bandits. You just see sequences of action and reward pairs. Okay. Consider a new site where a user arrives and an article must be chosen. Let the reward be binary, 1 if we click and 0 if we don't. Let there be K actions and T decision rounds. How can we do the explore exploit trade-off to be optimized? Well, we've got a bunch of articles, right? I guess this represent the K actions. And then we should try them all once, and we should start to prefer the ones that get clicked on, roughly. Mm-hmm. Certain rewards, partial feedback. When you select a particular action, then the rewards might be directly related to the action or not so related. Yeah. The goal is to learn a policy mapping context to actions. So, based on the context, you might choose a certain action, and in a different context, you might choose a different action. Okay, so I think this kind of makes sense, right? So they're formalizing the multi-armed bandit problem. And it's sort of like, how do we learn which levers to pull over time by trying them and getting outcomes and sort of improving our idea of which ones are the most rewarding? I think that's the basic idea. Yeah, that's fine. I think that fits pretty well. Sure, real justice. Wow, we just passed the 4 hour mark. I've been hydrating. I hope you're hydrating as well. Um, but yeah, this is probably a good breaking point. So uh, maybe I'll say let's stop here. But I hope you've seen that we have sort of traveled a pretty long distance over the course of this session. We've got our departments in order. We're starting to do real triage and get all of our specialists in line. We have the sort of ability to grow our departments as they get fresh work sent to them. We have a concierge that's learning the right way to route things, potentially routing among multiple candidates and retrying, and counting refusals as signal. We've got onboarding a department, which is taking the agents that we have sort of contemplated for our puzzle department, puzzle company, suburb. I don't know. Rig, of course, in the Gas City parlance, right? Um, and each one of them is going to be a department that accepts or refuses work and stays in its lane, contemplates whether work is part of its charter or not, and then we'll have the option as the mayor or the human to say, hey, this seems to be a missing piece in our organization. Let's create a new department to handle that. And have it work off certain sorts of sources, take certain perspectives on the work that's coming to it, use certain tools, make certain workflows work. And that's sort of how we're going to keep growing our organization as we find new jobs to be done as we're making puzzles. I hope that all makes sense. I hope this is entertaining for you as it is for me. Um, I'm really pleased that we're kind of finding a concrete implementation for these things that I was just thinking of as ideas by analogy from the human organizations I've been in. So yeah, um, let's start there, continue there, and here we'll pause right there. And next time we'll see what the mayor came up with. Okay. So I hope you have a great one.